What if there was a smart buoy in the ocean, running Edge AI, able to classify water quality in real time and remotely alert about dangerous levels of bacteria? I asked myself that question when I moved to Boston and learned that beaches often close due to high enterococci levels. But samples are collected manually, sent to a lab, and results take 24 hours or more, and only once a week. By the time you learn the water is unsafe, you might have been already swimming on it. That's why I built my own real-time classification model to predict bacterial contamination.
Okay, Nabu. Is it safe to swim at the beach today?
The enterococcus classification being safe suggests the water is clear of harmful bacteria. However, the water temperature is quite low at 16.44 degrees Celsius, about 61 degrees Fahrenheit, which might be uncomfortably cold for swimming. Recommendation: while the water appears microbiologically safe, the low temperature makes swimming inadvisable without proper thermal protection like a wetsuit. The cold temperature could lead to hypothermia if you swim without appropriate gear.
The system uses a tiny machine learning model trained with Edge Impulse, which directly runs on an SP32S3. It collects live data from 5 sensors: turbidity, water temperature, air temperature, TDS, and pH. The SP32S3 transmits the classification over LoRa. A second ESP32 with another LoRa module receives the packet and forwards the result over Wi-Fi using MQTT to Home Assistant. For this prototype, I couldn't mount the sensors on a buoy. The waves would make it too unstable. So instead, I collected water in a container right at a beach and placed the sensors inside it. The Edge Impulse model ran on the SP32 and the LoRa model transmit the classification directly from the shoreline. At home, the receiver ESP32 pick up those LoRa packets and send them through MQTT to my Home Assistant, updating water safety in real time. To train this model, I had to collect my own dataset. In total, I made 10 trips to the beach. Each day, after collecting sensor data, I took a water sample in a bottle, stored it in a cooler, and shipped it to a certified lab to measure enterococci concentration. Those lab results allow me to label each sample as safe or unsafe and use them to train my model. Inside Edge Impulse, I uploaded the dataset and created 2 experiments, one using spectral features and another using raw data. As you can see, the raw data model performed better than the spectral one, so that's the model I selected to deploy on my microcontroller. With the limitations of a small dataset, this is still a small-scale experiment, but it clearly proves the concept. With more data and better sensors, this approach could eventually become a real solution for public health. Thanks for watching.